day 3 of this amazing conference. When I was asked to give this presentation, I had a small problem, and that was, what would I talk about? I had so many different ideas and people who said, why don't you talk about this and why don't you talk about that? But what I really felt was important to get across was this place we are right now, and Dave just gave a beautiful intro to me. Thank you for your question about data. Because we're in a space where we have incredible amounts of information available to us, or potentially available to us. And I hope by the end of my talk you'll be able to have a look at some of the work you're doing and think about it a little bit differently. And also hope that it's a good segue into the final talk or discussion on partnering and how we do partnerships. I put in my title a grander view for our science, and that's because I think although it's incredibly important that our project-based activities are well done and that we use the right techniques and we use the right methods and we ask the right questions, there's also a view that the outcomes from doing that work have many, many different places they can be used. And it could be, in the case of one of my roles as the head of the herbarium, building up a collection, or it could be the kind of data we collect in our routine monitoring. But all these things can come together and provide this critical evidence that we've been talking about all week, that help us improve the lives of ourselves and all of the other lives that we're responsible for, the plants, the animals, the other people, and a whole ecosystem of the globe, as we just saw in that beautiful video. I think this conference, at its heart, is a testament to the fact that there's a very, very large commitment to improving natural resource management in South Australia and Australia generally. And I've seen, having worked extensively in 3 states now, I've seen a real shift in that over the last 15 years in particular, where now people think about and take natural resource management a little bit more seriously. It's not just viewed as a conservation activity anymore. It's a practical thing that we need to do. In the science space, I think there's 3 points that almost drive the way many of us have to work these days. We have to generate new knowledge through research, and doing that is becoming more and more constrained by resources, but there's more and more opportunities because of things like big data and sharing of resources and partnerships, and an awareness through partnering with government and research agencies. You can get more done, particularly when you have an interface with the community as well. That sharing of results through these data resources is a real value add for everyone, and there's also a greater awareness seeping into the research institutions culture that application of results of fundamental research on the ground has benefits to everyone, including perhaps some of our careers. So there's been a global trend in data sharing, and particular open data. The Australian government is supposedly committed to open data, and that we're all working towards that. The South Australian government has declared an open data policy. Academic discussion around the topic is happening. There's conferences on government sharing data, and there are even whole new investigative processes and open science frameworks being developed so that people can work their whole projects from beginning to end in this collaborative, open, sharing way. And it's a really big change from someone sitting in their office or in their lab, beavering away, writing things in their hardbound notebook, which they may at some point in the next 5 years or 10 years or 20 years actually do something with. So it's a fundamental shift that leads to these very large data sets. and also a rapidity in being able to respond if we can handle the data. This is my placeholder slide. This is what, if you came to one of my research talks, I might show you my wonderful research on the evolution of marine plants. I've put it here because I think there's a fundamental assumption that this kind of research is distant from the research that we do to solve problems on the ground. And that's simply not the case. More and more we can use these kinds of data sets to inform decision making in a whole range of ways. It can be as simple as having good taxonomic concepts so we know what species we're working with. It can be as important as knowing which groups of organisms have a very ancient evolutionary history, so therefore we protect them and manage them in different ways. But these days, these kinds of data sets are coming up hard and fast against other data sets which might be in engineering work or changing water tables and trying to understand them all together. I thought it was worth giving you a little bit about my perspective on this. I have a joint position between the Department of Environment, Water and Natural Resources and the University of Adelaide, and I'm firmly embedded in both. And as someone just mentioned to me, my life is a Venn diagram, all overlaid on top of each other. But in my government role as Chief Botanist, I'm the head of the herbarium. I'm actively involved with a number of taxonomic, systematic, evolutionary projects. I'm currently the chair of the Council of Heads of Australasian Herbaria, so I have a national and international role there. And the herbarium, the State Herbarium of South Australia, is a very outward-looking unit. It might not seem so, but I don't think I'd be too far wrong if I said the wider public of South Australia probably knows more about the herbarium than the rest of the department does. But that's okay, because that's who we're trying to communicate with. They come into our space, they work with us, they bring us plants to ID, our staff go out and work with them, in particular our weeds botanist who goes out and does training. So we're an outward-looking part of the department. I'm also part of the leadership team in Science Monitoring and Knowledge, where we, particularly over the last 2 years, have been building a whole new approach to how we deliver science in the department, and you're going to have a few people talking to you about that after my talk. I also have a fairly strategic role in research partnerships, including capacity building and forward planning, and I share some space in time occasionally with Jenny Fluin and Neil Powers, who's our engagement with the Goiter Institute, and we all try to look forward and think of things in the future. My university role, standard academic role, although a small part of it, but I've taken on board the idea that my role should also be in that Venn diagram model at the interface, including some situational collaboration, I've called it, but it's around supporting new initiatives and not necessarily doing them myself, but helping researchers and the government get it right, with the concept of fit for purpose in there. And then I have my own research program where I do, or mostly my staff and students do, the things that I've been working on for the last 20 or more years. So from that perspective, I'm involved with a number of research centres, and I have a number of research programs as a university researcher. As a government scientist, I'm involved with a whole bunch of fundamental and applied science. So my perspective is coming at it in multiple directions every day, all the time. So when I say that our science today is involved in the generation of new knowledge and as well as science used in decision making, I'm seeing that every day. I'm seeing the tension between the two and how they can complement each other. The generation of new knowledge that stretches boundaries and what some people might call blue sky can be incredibly inspirational and exciting, but in the applied science space, applied science is often built on this so-called blue sky or fundamental science. And to do it well, you need to have good skills in integration, synthesis and translation. And I think that's the space in which many government scientists are now recognising they need to improve their skills. We heard on Wednesday in the introduction from our Minister and our Chief Executive that they see what we do as important, that we should be building better evidence bases to support decision making, and Sandy Pitcher in fact challenged us to see better ways of doing that and how we can improve that and how we can improve our communication of that. And so I see that as this three-way interaction between the science itself, that science becomes evidence, or the data collection can become evidence, and the application of that. And that isn't always in one direction, although most people would tell you it is. It does have a return mechanism, and that sometimes we call it things like adaptive management or cyclic processing, but it is an interacting process. So I've got these funny little diagrams down the side: where, how, why and what. And that's because I think there's four components to these interactions for it to work well, and I'm going to share some examples based on my own research program, and I'm unashamedly going to talk about my research, not others. So the where does the science we use come from? And for this I really wanted to make the point that sometimes we talk about data, but when we're really talking about collaborations. A whole bunch of video files is not data. It has the potential to become data. If we manage it well, we collect the metadata, we can process it and interpret it. But if all it ever does is stays a pile of video files, it's only ever going to be a pile of video files. And one day we'll lose contact with where they were collected, what they were for, and even what is on them. And despite the fact, if any of you were at Robin Barker's talk yesterday on working with really old type specimens in the herbarium collections, you can become a bit of a detective and sleuth your way out of these problems. It's really often not worth the effort. So you have to now be making a choice when you collect these things that we want to be data, that you're actually going to turn it into data. And that's one of the things I've seen more and more. We have incredible resources that as yet are not data, but they are what I'll call collections. How is our data obtained? And for those of you who've seen the poster that was outside, which you're going to see snippets of the rest of the talk, that the Knowledge Management Unit put together on information stores and data stores, it gives a really good idea of what I'm talking about here. There's data value chains all throughout what we do and how we do it, and we also need to be aware of where that's going. And then, why do we need fit-for-purpose evidence? So we don't just magically use information well. It's not necessarily magically collected well. It's done very strategically and with purpose. And getting the question right to fit the purpose is, I think, probably the most important thing that government scientists need to do or need to learn to do better. And then, how is data applied? And what are desirable outcomes? Because obviously there's lots of things we might want to do with the information we have available, but it may not always be possible. So this is that poster I referred to. I'm only going to put it up to highlight that we have the data flow in this particular case is from where we get the data from, these things on the left side, and in this case there's three categories of government, universities and industry, but I would probably equally, you could call them other things. And then there's the data stores themselves. Sometimes they're big databases, sometimes they're a thumb drive from what someone had on their C drive on their computer that may have ended up at home. Sometimes they're on a shared resource. So it can be all of these things. And then we have the online available data sets. And South Australia is actually very far ahead in this space in general. We have a lot of resources online, and in particular the EnviroData SA program has opened up a number of access to a number of resources. So those data sources that I mentioned, if you look at the data sources that are available in the South Australian Government, we have a whole bunch of different projects, programs, M&E, research partnerships, etc. And there's a few of them that have got coordinated results going into a database, but certainly by no means all of them. I was actually somewhat horrified when I first started working here 5 years ago at the fact that some really important data sets weren't very well managed, and that has changed over the last 5 years, which is a really important step forward. I'd have to say though that it's very dependent on having someone who's an advocate for data management, and we still haven't quite got into our headspace that it's something fundamental to what we should be doing. University researchers generally don't see the point because they want to use their data for themselves. Most of them will be willing to share their data with you once they've published it, but beforehand it's often difficult to get it. And then industry data is often locked away in confidentiality agreements, or if not, is usually very similar to the government type of data. So the examples I'm going to be shameless in talking about things that I'm involved with or have been involved with. I'm not only going to talk about South Australian work because I still work a little bit all over the world. And I'll briefly talk about EnviroData SA because I actually think it's a really important resource that we should all be aware of. I'm going to talk about the herbarium and the importance of taxonomy, of course, because I'm the chief botanist and I felt like I should, and I wanted to. I'm also going to talk about connectivity and thresholds in marine plants because that's one of the areas of research that's really coming to fruition now for me, and I'm going to briefly finish on the value of restoration. So EnviroData SA, I hope you all know this website well. If not, go home and look it up. The content EnviroData SA, some of you may know WaterConnect. It's all a similar resource, it's all coming together, and it brings together all the different bits of information that we've been able to put in there, and it's growing in its expanded form, and we're trying to make it more useful. If you looked up a region, you'd start seeing lists of different things, and down the bottom there's some little tabs. Have I got my button? These tabs along here, I don't want to turn this into a how to use a website thing, but there are a lot of different resources, including actual publications, plus a whole range of data systems. So you can actually get into all of these things, and they're all available every day. Some of them are updated regularly, some of them aren't, and that's a moving feast at the moment, but the intention is in the future to build a sophisticated thing. I mentioned earlier that there's a difference between data and collections. Probably an easy to understand version of that is a herbarium full of dried plant specimens in boxes. That's great, we know they're there because there's a box that says the name on it. But actually what it ends up being is everything on the left there. And that's a map of all of the daisy family records held by the State Herbarium of South Australia, coloured by different species. So there's a lot of data that we hold in the form of the specimens and the label data and their species ID that's happened since then. So it's a really important link between a collection and something that then gets used in lots of ways. How do we get our data? A typical project, and by that I'm saying I've got to work out this problem, I'll do this, or a researcher at a research institution might say, wow, I've got this cool thing and I'm going to do this. We do try to build on current state of knowledge, But the critical first step is where is the data, is it appropriate for my use, and is there someone who knows more than me, so is there an expert out there who can help me? If you don't get good answers to that, most people start with something like a lit review, or these days a meta-analysis. Or if you're a bit more sophisticated, you might try some analytics like Google Analytics, but in reality, you're limited by your exposure to data sets. So the more data we get into these resources, the better. As I said earlier, there's a lot of different types of data sets in South Australia available, and we're very, very lucky that these data sets are, many of them are available online and have been for quite some time. So people are very familiar with it. When I first started getting interested in whether we should upgrade the Herbarium's eFlora system, I started asking around the consultancies around town, and a lot of them use this system almost every day because it's the way that they identify their plants, it's the way they do their work. Core data sets include three main types. I tend to think that they are those that are associated with collections, like herbarium collections, but also biosecurity is a whole range of water data sets that probably sit in this space. They could be associated with surveys, or they could be associated with ongoing monitoring. They're the ones that tend to be included in those ones that are already available. But there's probably tens of thousands of other data sets that might be able to be shared. There's a really important step in here, and that is we need standards, and we need an agreed upon move forward. And there's some really interesting literature evolving in this space, but it's something that, again, we've been working on through developing a managing environmental knowledge framework, which, you know, you should all read. If you want to follow a data value chain, an easy one to track through is what happens with the herbarium data set. Herbarium data is based largely on the fact that a plant specimen is collected in the field and it becomes incorporated into our herbarium collection, and that involves these steps of it obviously being processed and arriving, but it gets identified by a taxonomist. And that's an important step because there's some authority associated with that. That then gets included in the data record, and then those data records get delivered overseas, interstate, all over the world, and people can search on that data. The data gets used, then we can do things like draw maps. But one of the things that's intimately associated with herbarium specimens is taxonomy. The two things are synergistic, interacting, they live together, they breathe together, they change together. And by that, we need to be aware that the names on a specimen change as taxonomy changes, and taxonomy changes as we get specimens and review them. So there's this interaction, and that means that over time, the names of things can change, and so therefore your downstream data effects can change. And that's a critical thing, that's one of the tasks of a herbarium, is to keep those things up to date, and also to be involved or do the taxonomy that leads to those recognition of new species. That kind of work has led to the growth in the number of species present in South Australia that we recognise, as well as the fact that we like to import weeds. Our data usage for these online databases is growing dramatically. Our own South Australian site gets more than 1 million page views a year, and the data downloads from our online presence through the Atlas of Living Australia and Australia's Virtual Herbarium this last 12 months is over 42 million records downloaded, which is just phenomenal. Our data gets used in unexpected ways. Now, you've seen this figure twice already during the conference. Craig Liddickett is a student working with us, and one of the layers in his analysis of the relationship between a whole bunch of drivers and health, respiratory health, was species richness, and it's a layer that's generated out of the kind of records that I'm talking about, herbarium records, field observation records. And that species richness association is a positive effect of health. You're healthier if you have higher species richness. And that kind of analysis is possible by having these resources available and being able to share them all online. Why do we want fit-for-purpose science? Well, other than money, there's a couple of other reasons. There's an issue to do with time. And time isn't always money. Sometimes time is time. And time is when you need to make a decision quickly and you could throw $1 gazillion at something and it wouldn't help. You sometimes need to be able to make decisions quickly. And so therefore you make the decision in context of the information you have available. And this can be very challenging. We can all get frustrated with it. But in doing that, we think about what the end-use requirements are, and that includes assessing the risk-reward and the opportunity for doing it differently. I think as long as we do that well and clearly and document it, I think it's an acceptable way to go, but we want better data sets to do that with. To get better data sets, we've gone down the path of saying research partnerships are core to that. And again, you're going to hopefully hear a bit about that in a minute. But one of the best outcomes that we get are from genuine partnerships between researchers and the end-use stakeholders. And it's best when they get embedded in the program. So just very quickly, some work doing this in the Great Barrier Reef region. We had a partnership between all these different institutions, and where we had a good conceptual framework to study seagrasses. We find a whole bunch of things that we can measure change over the course of environmental responses. And in this case, this is the change of phenology, or the size and the shape of leaves of seagrasses change. And they change because of an event. In this particular case, it was a cyclone. And what this data is telling us is that as things recover, they look different. And so you can't make assumptions based on looking at one or the other. And this kind of information's gone into looking at a long-term index of the health of seagrasses in the GBR. And what we've seen is we're now seeing recovery after the big events of 2010-11 of the coastal seagrasses in the GBR, which is a bit of a relief, although that may have changed after this last few weeks with all the heat up there. The other thing we can do is we can use new tools, and we're starting to integrate things like molecular genetic data into looking at how systems recover. And this is some work my team has been doing, looking at scales of connectivity, which are leading to understand timeframes for recovery. And then when we apply this kind of science, in this case there's some work off the coastal Virginia coastal bays, we can also begin to document here the amount of money we've saved by restoring a system relatively quickly. And this work has really given some impetus for the region to put more effort into restoration. So I'm going to just finish up by saying I'm a botanist, and that's okay. For those of you who haven't heard about this, it's a little program where people are trying to reclaim being botanists, because it's a word that's gone out of fashion. And I'll just thank you all. Jenny.
Thank you, Michelle. I guess illustrating the duality of her role, there's no time for questions. But Michelle will be around at morning tea, and she's at the university, and she's with us in Juna, and contact details are all in the program. Next up, we have a fantastic discussion, kind of debate, keynote altogether. First of all, we have Sandy Carruthers, who is the Director of Science Monitoring and Knowledge in Juna. She's also my lovely boss. We have